Hi, we continue with 2.5 momentum. Okay, so you look at all the important facts about momentum. Look at number 1, the definition for momentum. Momentum of an object is defined as the product of mass and velocity, or momentum equals to mass times velocity. Or we can write the symbol for momentum, small p, equals mass m multiplied v, velocity. So we have p equals mv. Number 2, the SI unit for momentum is kg meter second negative 1 or Newton second. So these two are equivalent unit. Normally we use kg meter second negative 1. Number 3, momentum is a vector quantity, so it has direction. The direction is same as direction of velocity. Number 4, when the mass of the object is kept constant, velocity is directly proportional to the momentum is directly proportional to its velocity. So you can see from the formula here, there are two factors that affect momentum, mass and velocity. When velocity of the object is kept constant, momentum is directly proportional to its mass. Meaning, the higher the velocity, the larger the momentum. The larger the mass, the larger the momentum. Number 6, the related principle, which is very important, the principle of conservation of momentum, which states that in a collision, total momentum before collision is equals to total momentum after collision, or we can say total momentum is conserved, provided that there is no external force acting on the colliding objects. 7. In a collision system, then we can summarize the principle of conservation of momentum as total momentum before collision equals to total momentum after collision. Or we can say total momentum of the system is conserved. Conserved means remains unchanged. Okay, now when we talk about collision, we will discuss about 3 situations. The first one, we'll discuss about elastic collision. The situation given here, we have one truck and one car. This is what happened before collision. This is during collision, and this is what happened after collision. So the situation is about two objects. After collision, two objects will separate and move with different velocities. Total momentum before collision equals to total momentum after collision. So for this type of collision, so we can apply principle of conservation of momentum because no external force acts. Okay, no external force act on both of the object. So let's say we label mass of the truck 1 is m1, initial velocity is u1. For the car, mass is m2, initial velocity is u2. During collision, the truck and the car collide. After collision, the truck will move with velocity of v1, final velocity of v1. The car will move with final velocity of v2. So we can use principle of conservation of momentum. Thus we can write total momentum before collision is momentum of the truck plus momentum of the car equals to after collision momentum of the truck plus momentum of the car. So go to the formula of momentum, P equals to mv. M here is v1, V equals to U1. Then momentum of the truck is M1 U1 plus momentum of the car M2 U2 equals to momentum after collision M1 V1 plus M2 V2. So we have this like general equation for elastic collision. Normally for elastic collision, the two objects will move separately after collision, and the total kinetic energy of the system is conserved, meaning the total kinetic energy before and after are same. So this one is elastic collision. Second type of collision, we have inelastic collision. Okay. Let's say we have the same situation. So we have a truck, initial velocity U1, and a car, initial velocity U2. After collision, the truck and the car move together with common velocity V, like stick together. Okay, so they have one common velocity V. After collision, two objects will move together with common velocity. So this type of collision, we also can apply principle of conservation of momentum. Total momentum before collision equals to total momentum after collision. So what we can write here, momentum of the truck before collision M1 times U1 plus momentum of the car before collision M2 times U2 equals M1 and M2 stick and move together. This one is like form one new object with total mass of M1 plus M2. So they move with common velocity V, right? So they have this general equation. So for this one, inelastic collision, normally after collision, the two objects will stick together or move together with common velocity. So we have this general equation for inelastic collision. The difference between elastic and inelastic is, for elastic, the two objects move separately after collision and the kinetic energy is conserved. For inelastic, the two objects move together with common velocity, or they stick together after collision, and the total kinetic energy is not conserved. So this type of inelastic normally happen during serious accident. So you can see most of the kinetic energy is lost as heat and sound. That's why kinetic energy is not conserved. Okay. The last one is explosion. Explosion, example is a cannon and cannonball. Okay, we have cannon and cannonball. Initially, before explosion, you can see the cannon and cannonball. The cannonball is inside, or the bullet, like bullet and the gun. Okay, so this one both at rest before explosion. So we can say total momentum before explosion equals to 0. After, this one is after explosion, so what happened? The cannonball is fired out. The cannonball is fired out. The cannon moved backward. Okay, so the total momentum after collision is also 0. Okay, so look at the explanation. After explosion, two objects will move separately and move in opposite direction, or opposite velocities, in opposite direction. Total momentum before explosion equals to total momentum after explosion. So this one also, total momentum is conserved. So we can write this way. Total momentum before explosion, 0, because the cannon and cannonball at rest, both at rest before collision. So total momentum 0. After explosion is the momentum of the cannonball plus momentum of the cannon. So we have m1 v1 plus m2 v2. If we rearrange the formula, we get negative m1 v1 equals to m2 v2, meaning momentum of the cannonball is equals to momentum of the cannon but in opposite direction. That's why when you total up, you will get 0. Okay, negative m1 plus m1 v1 equals to m2 v2. Example, like if we have momentum of the cannon is 50, momentum of the cannonball is negative 50, so the total is 0. Okay, so we have 3 types of situation here: explosion, inelastic collision, and elastic collision. So all these 3 situations we can apply principle of conservation of momentum. Okay, now let's look at definition. Complete the I-think map below. You can try to complete it by yourself. So what is definition for momentum? It's a product of mass and velocity of an object. The formula, just write the symbol P equals mv. The SI unit, kg meter second negative 1 or Newton second. Type of quantity is vector quantity. So this one you can complete by yourself. Okay, principle of conservation of momentum. This principle is very important. There are many applications based on this principle of conservation of momentum. So look at the difference between elastic and inelastic. Okay. So we have elastic collision. Total kinetic energy is conserved, meaning when you calculate the total kinetic of both objects before and after, the total remains unchanged. So we call it conserved. Total momentum, conserved. Total energy is conserved. For elastic collision, 2 objects will move separately with different velocities. The velocity can be, the speed can be same but opposite direction or in the same direction. Okay, 2 objects will move separately after collision. Total mass, of course, conserved. Okay, look at inelastic collision. Total kinetic energy is not conserved because most of the kinetic energy lost as heat energy and sound energy. So for inelastic collision, example is serious accident. Okay, that one will cause some of the energy loss as heat and sound. So kinetic energy is not conserved. Total mass conserved. After collision, 2 objects will move together with common velocity. Okay, like stick together and move with common velocity. Okay, look at the Uji Kendiri 2.5, some of the example problem solving. Number 1, a bullet of mass 10 gram fired from a rifle of mass 1.5 kg. The velocity of the bullet and rifle are 250 meters second negative 1 and 6.5 meters second negative 1. Calculate the momentum of the bullet and the rifle. Okay, the solution for this one. Momentum of the bullet, so use formula P equals to mv. The mass of the bullet, 10 gram, 10 gram must convert to kilogram, so 0.01 kilogram, multiply velocity of the bullet, 250, so we get 2.5 kg meter second negative 1. Okay, momentum of the rifle, mass of the rifle 1.5, and the velocity, why we put negative? If you still remember, velocity is vector, and the momentum also is vector, so direction is very important. So you look at 6.5, is direction is opposite to direction of 250 meters second negative 1. If we assume direction to the right is positive, here we put positive sign, meaning 6.5 you must put negative sign. Okay, then we get negative 9.75 kg meter second negative 1. So you can see the just calculate. If we say something like, you can see clearly here is not conserved, just answer the question. Maybe there's something wrong with the value. Actually we should get same momentum, because total momentum is conserved. Okay, number 2. A lorry of mass 1000 kg is moving with velocity of 5 meters second negative 1, collide with a car of mass 800 and move with 2 meters second negative 1. After the collision, the car moved with velocity of 3 meters second negative 1. What is velocity of the lorry after the collision? Okay, so this one is like elastic collision, move separately. The lorry and the car move separately, so they have different velocity. Okay, so we have total momentum is conserved, or we can say that total momentum before collision equals to total momentum after collision. So for this type of question, I always sketch a bit to show the direction. So in this case, there's no opposite direction, so all the value of V we put as positive direction. Okay, so M1 is 1000, U1 is 5, M2 is 800, U2 is 2, and then substitute M1 1000, we want to find V1, then M2 800, V2 is 3, then you solve, you will get V1 4.2 meters second negative 1. Meaning after collision, the two objects move separately in the same direction. If they are moving to the right, means they still maintain direction to the right. Okay, this one. Okay, this one after collision also moves separately, so meaning this is elastic collision. So but you must be careful with the direction. If we take direction to the right is positive, means direction to the left should be negative. Okay, so use the formula M1 U1 plus M2 U2 equals M1 V1 plus M2 V2. So you can see for M1, the mass given in gram, you convert to kilogram, multiply with 2, positive because to the right. Okay, and then for B, the mass also convert to kilogram, multiply, this one must put negative sign. So you can see direction is negative to the left, so put negative sign. If you don't put negative sign, your answer will be different or will be wrong. Okay, so M1 V1, look at A again, left, move to the left, so you must put negative sign. For B, we can assume to the right, so don't put any sign for V2. Okay, we just calculate for V2. Okay, then V2, 0.25 V2 equals 0.75, then we get V2 is 3. Just now we put V2 as a positive sign, positive sign for V2, so you get positive answer, meaning B is moving to the right. If suddenly you calculate for V2, you get negative value, meaning B is moving to the left. Okay, number 4. calculate the common velocity of the fishes after collision. This is before. The big fish swallow the small fish and move, meaning the fish is inside, the small fish is inside the big fish. Okay, so this is inelastic collision. Okay, so you have the formula. Generally we can write this way: m1 u1 plus m2 u2 equals bracket m1 plus m2 v, common velocity, because they have moved together, like stick together and move. The small fish is inside the big fish. Okay, so m1 convert to kilogram, the mass, 0.45 times 2 plus 0.15 times 0. This is at rest, so meaning initially the small fish is at rest, so 0. And then after collision, move together, so the total mass m1 plus m2 v. So you solve, you will get v equals 1.5 meter, second negative 1. Alright, number 5. Number 5 shows a man jumps out from a boat, calculate velocity of the boat. So you can see before, this is one type of explosion case. Initially, before the man jumps, the man is standing at rest in the boat. Okay, standing at rest in the boat, meaning total momentum before collision is 0. So this is explosion. Or we can say that m1 v1 plus m2 v2 equals to 0. Or negative m1 v1 equals to m2 v2. So you can assume m1 as the boat. Okay, the m2 is the man. So for the boat move opposite direction as the man. The man jumps to the right, the boat moves to the left. Okay, so here we get negative 20 v1 equals to 90. So v1 we get negative 4.5. Okay, because the v2 you put positive sign, meaning you assume to the right as positive. Then you get v1 negative, meaning the boat is moving to the left. Okay, or you can say if the man jumps forward, the boat moves backward, so that the total momentum is conserved, that is equals to 0. Okay, so this is all about momentum. So you must be familiar with the definition of momentum and the formula and the type of explosion, elastic collision and inelastic collision, and how to solve calculation problem regarding this one. Okay, you can go and search in the internet about the application of the principle of conservation of momentum. Okay, so that's all for this part.